Got an email today from a student wanting help on the problem that you can see on the screen here. And the problem talks about Chebyshev's rule. And the question says this: at least 99.31% of the data lies between how many standard deviations of the mean? And then explain your answer. So, Chebyshev's rule talks about if a distribution is not normal. So when will you use Chebychev's theorem is when you have a distribution that is not a normal distribution. If you do have a normal distribution, that's an empirical rule. So just in case you forget what a normal distribution is, so for a normal distribution looks like a bell curve, and the bell curve says the further you get away from the mean, so here's the mean, that's just the average, the further you get away from the mean, the less likely it is that an event will happen. So you can see the height of this graph talks about the likelihood that something will happen, and the further you get away from the mean, the less likely it is to happen. So if you use a normal distribution, use the empirical rule. The empirical rule says that if you're within one standard deviation, that is going to include 68% of the data is within one standard deviation of the mean. 2 standard deviations from the mean will be 95%. And then 3 standard deviations from the mean will include 99 points. Oh goodness, I forget what it is. I think it's 99.7% of the data. That's great for a normal distribution, but here they're not asking, they didn't say that we had a normal distribution. They said that we have a distribution that's not normal. If you have a distribution that's not normal, what we use is we use Chebyshev's rule, and Chebyshev's rule says that at least 1 minus 1 over k squared standard deviations, in this case k represents the number of standard deviations, of the data will be between this percent of the data. So there we'll put in our percent as a decimal. So the student emailed me, and their problem had 99.31%. So I'm going to use this formula here and put 0.9931 and then get k by itself. And there's lots of good calculators to solve for k. And so, we have things like, Mathway, we got things like Photomath. I know about these things, they're not a secret. We have things like, what's the other one? Wolfram Alpha. All of these websites can solve this equation for k, but we can also do it by hand. I can get k by itself by hand. Let me show you how we can do that. 1 minus 1 over k squared equals 0.9931. This is the formula. This is the percent that they gave me. We use Chebyshev's rule. This is Chebyshev's rule right here. And get k by itself. So what I'm going to do is I am going to move this term to the other side of the equal sign by doing the opposite. The opposite of subtraction is addition. So now 1 is by itself, and I got 0.9931 plus, that was the opposite of the minus there, 1 over k squared. Now get k squared by itself, so I'm going to move that decimal to the other side. 1 minus 0.9931, I believe that should be, let me double check that with the calculator. That's 0.0, let me give myself some more room here. So 1 minus 0.9931, that is 0.0069. Now we have 1 over k squared by itself. And now what I can do to get k squared is cross multiply. And when I cross multiply, you got to set those equal to one another. So that's 0.0069 k squared. That's what happens when you multiply the two. 1 times 1 is 1 on the other side. So when you cross multiply, you set the cross products equal. Now get k squared by itself, so I will divide both sides by 0.0069. 0.0069. Let me figure out what that is. Give me just a second. I'm using my calculator here. 1 divided by 0.0069 is 144.927, etc. So it's pretty close to 145. Pretty close. So that would tell me that k squared equals about 145. It's 144.928 around. And now how do I get k by itself? Is undo the square with the square root. The square root of that, square root, would be pretty close to 12. Pretty close to 12. So in this case, we can say that, 99.31% of our data is between 12 standard deviations above and below the mean. Okay, so I hope that helps not only the student that emailed me, but all of the students. Okay.